Assalamualaikum and hi students. So this is a lecture video for BMCG 1013 Differential Equations. Chapter 4 Fourier Series. So the three LOs that will be covered in this video are to describe the predict functions, to determine even, odd and neither even nor odd functions, and the last one is to determine the Fourier series of full range. 4.1 Predict functions. A function ft defined on interval negative L to L is predict function with period of t equal to 2L. T is the period, okay? From negative L to L, so we have t equal to 2L. If ft plus capital T, the period equal to ft, and capital T, the period must not equal to 0. If capital T is equal to 0, then you have ft equal to ft. So there is no use. Okay. So the smallest positive value of capital T, the period, is called the fundamental period. 4.2 Even and odd functions. So let ft be a real value function of a real variable. Then ft is even function if f negative t is equal to ft. When you substitute this t with negative t, so you have your ft back. Okay, and the graph of an even function is symmetric about the y-axis, while for the odd function, if f negative t is equal to negative ft, f negative t can be written as negative ft, and the graph for odd function is symmetric about the origin. So basically, for even function, if you have this line for ft, so it is even function when it's symmetric about the y-axis. So if you have this graph, so it is an even function. But for odd function, if you have this line and then it's symmetric about the origin, means you have reflection on y-axis and then reflection on x-axis. So this is an odd function. Example for odd function, and this is example for even function. Okay, it reflects on y-axis for even, and for this it reflects on origin. 0, 0 means it flips to y-axis and then x-axis. And for the basic properties for even and odd functions, so you have, if you have even function plus or minus with even function, you have even function. Even function multiply or divide by even function, you have even. Odd plus minus odd, you have odd function. Odd multiply or divide by odd, you have even function. Odd multiply or divide by even functions, you have odd. And the last one, even plus minus odd function, you have neither even nor odd function. We will see this on the next example 4.1. Example 4.1, determine whether the given function is even, odd or neither nor. Okay, we start with A. ft is equal to t square. Okay, so if we check for f negative t, we have negative t square, and negative t square is equal to t square, and t square is our original ft. So since f negative t is equal to ft, so this is our even function. Okay, and if you look at the graph for t square, a quadratic, we have this kind of graph. So you see it reflects on y-axis. So when the graph is symmetrical about the y-axis, so it is even function for A. And then moving to B, you have ft equal to t cube. Okay, again, substitute t with negative t. You have negative t cube. And negative t cube is equal to negative t cube. Negative t cube is equal to our ft with negative in front of it. So we have negative ft. Okay, so for ft equal to for f negative t equal to negative ft, it is odd function. And if you refer to the graph, the cubic, okay, you have this kind of graph. This is your t. So if you see here, it reflects on u first, and then reflects on, y first, and then reflects to x. So it is symmetric about the origin. So it is odd function. Okay, that's how you determine if it is even or odd or neither nor. Using the substitution of t with negative t, or you can refer to the graph. Okay, A, B, and then for C, let's say for C, you have ft equal to exponent t plus exponent negative t. Then find what is f negative t. Substitute your negative t. So exponent negative t plus exponent negative t. And this is equal to exponent negative t plus exponent positive t. And if you refer to this ft, it is equal to your ft. So f negative t equal to ft, then it is an even function. D, okay, D, you have fx equal to x cos x. So f negative x is equal to negative x cos negative x. Okay, from the properties, negative x cos negative x is equal to positive cos x. Okay, cos negative x is equal to cos x. So you have negative x cos x. Refer to fx, this is your negative fx. So meaning that D is odd function. Okay, or you can refer to these basic properties. Okay, odd multiplied by even, it is odd. Okay, so you know that x is odd function. X is odd function and cos x is even function. So odd multiplied by even, you have odd function. Example E, you have fx equal to 3x cubed minus 2x squared plus x plus 1. F negative x is equal to 3 negative x cubed minus 2 negative x squared plus negative x plus 1. This is equal to negative 3x cubed minus 2x squared minus x plus 1. Okay, so is it equal to f negative x? Sorry, negative fx. So what is our f negative fx? So supposedly it becomes negative 3x cubed plus 2x squared minus x plus 1. But now you have negative x cubed plus 2x. But here you have negative 2x squared. So it is not equal to your negative fx. And obviously it is not equal to your fx. So now this is an example for neither nor function. Okay, neither even nor odd function. So neither nor, because this f negative x is not equal to negative fx or fx. Okay, And if you look at this, this is x cubed is odd function. X squared is even function. X is odd function. Okay. So if you refer to the basic properties, even plus minus odd, you have neither even nor odd function. Last, when you have fx equal to x cubed sine x. F negative x is equal to negative x cubed sine negative x. Negative x cubed is obviously negative x cubed, and sine negative x. Okay, using the trigonometric identity, this is equal to negative sine x. So you have negative sine x. So you have positive x cubed sine x. And refer back to your fx, it is equal to fx. So for this, this is your even function. And you know x cubed is odd, sine x is odd function. Odd function multiplied by odd function is even function. So that's why it is even function. Okay, I have another example. What if you have ft equal to exponent t? Is it neither nor or even function or odd function? Okay, so find what is f negative t. So f negative t is equal to exponent negative t. Okay, exponent negative t is not equal to your ft because your ft is exponent t, and it is not equal to negative ft because negative ft should be equal to negative exponent t. So for this example, you have neither nor function. Okay. The last subtopic in this video is to solve for Fourier series of full range. Okay, so 4.3 we have Fourier series. Fourier series is a series representing real periodic function fx as an expansion in a series consisting of sines and cosines. So it involving sines and cosines. Let fx be a function defined in the interval negative L to L. X is from negative L to L. And fx be periodic with period t equal to 2L. In periodic function, in Fourier series, we have this formula. If the function fx is either continuous or has finite discontinuities at some points in the interval, then the Fourier series for fx is given by this formula. Fx is equal to a0 over 2 plus summation n from 1 to infinity multiplied by an cos n pi x over L plus bn sin n pi x over L. Okay, where you need to find the Fourier coefficients. A0, what is A0, an and bn. To find a0, an and bn, you need to solve for this integration. For a0, we have 1 over L, integration from negative L to L, the interval from negative L to L, fx dx. For an, you must multiply your fx with cos n pi x over L. And for bn, you multiply fx with sin n pi x over L. Do the integration respect to x. And L, to find L, L is equal to t divided by 2. T is your period. But if your fx is an even function, so you have a simpler formula for even function, where you have fx equal to a0 plus 2, a0 divided by 2 plus summation n from 1 to infinity, an cos n pi x over L. For this, you don't have to find what is bn because we assume bn to be equal to 0 because it is even function. Okay, so just find what is a0 and an. Okay, instead of using 1 over L from negative L to L, now we have 2 over L multiplied by integration from 0 to L. We just assume it is symmetric. No, it is symmetric. about the y-axis. So we can assume the value on the left hand side is equal to on the right hand side. So we can multiply 2. So 2 divided by L, and we just consider half part of the interval from 0 to L. Okay, the rest is the same. You need to integrate fx, and for for an, you integrate fx multiplied by cos n pi x over L. If it is odd function, the formula will be even simpler. Okay, you just need to find what is Pn, and as your a0 and an is equal to 0. So just find Bn. Bn, we assume it is equal both sides, on the right hand side and on the left hand side. So we just have 2 over L, and the interval is from 0 to L. And before we start with discussing on example 4.2, we have some helpful identities for calculating Fourier series coefficients. So just remember that sin negative x is equal to negative sin x, cos negative x is equal to cos x, sin n pi and sin 2 n pi is equal to 0. Both sin n pi and sin 2 n pi equal to 0. And last, cos n pi equal to negative 1 to the power of n. And if you have cos 2 n pi equal to 1. Okay, you need to remember this. Okay, so you don't have to use your time using the calculator. We have 3 examples in example 4.2. Okay, question number 1. Okay. A periodic function is defined by, let's say you have fx equal to 0 for interval negative pi to 0, and x for interval 0 to pi. Okay, fx plus 2 pi equal to fx. Okay, for this one means x, this is t plus capital T. So your period is 2 pi. T is equal to 2 pi. So L is equal to T divided by 2, means L is equal to 2 pi over 2, and L is equal to pi. Okay, so this is how you find the L. Or this is negative L to L. Okay. So negative pi to pi. Okay, so you know what is your L. The first one, you need to sketch the graph of fx. Second one, determine whether the fx is even, odd, or neither. And the third one, C, compute the Fourier series of fx. So let's start with A, sketch the graph. So to sketch the graph, okay, you have negative pi, this is your x, and this is your fx. You have x from negative pi, 0 to pi. Okay, so for negative pi to 0, you have 0. So 0. So you have this line from negative pi to 0. And then from 0 to pi, you have x. So it's a linear, it's a line. So this is your x. Sorry, this is your pi. So you have this kind of graph. So your period now is negative pi to pi. What if I change the question? Sketch the graph of fx in interval negative 3 pi to 3 pi. Okay, so for this question, you need to extend your x and y. So this is 2 pi and this is 3 pi. Then you need to have your negative 2 pi and negative 3 pi. And then just copy your line, okay, your function, this function. So from pi to 2 pi, you have this. And then from 2 pi to 3 pi, you have this line. Again, for this one, you have 0 to this one. Okay, repeated. Okay, it repeat for other period. For this period and this period. It repeat the same form of line. The same shape of the line. Okay, so you are done with A, and then for B. For B, you need to determine whether the fx is even, odd, or neither. No. So refer to the A. Okay, refer to the graph on A. So is it even? If it is even, you have this kind of graph. Okay, but if it is odd, you have this kind of graph. So this is a neither nor function because it doesn't reflect symmetrical on y-axis or origin. So it is neither nor function. Okay, and the C, for the C, since it is neither nor function, so you need to find all the Fourier coefficient. You need to start with finding A naught, AN and BN. So formula for A naught, we have 1 over L, integration negative L to L, fx dx. Okay, so L, you know your L is equal to pi. So 1 over pi, negative pi to pi fx dx. So since this is a piecewise function, so you need to split your integration. Okay. So from negative pi to 0, negative pi to 0, your fx is 0. So 0 dx. Plus from 0 to pi, your fx is x. So you have x dx. So integration 0 is equal to 0. So you can just ignore the first term. Okay, continue integration. So you have 1 over pi. Integration of x is x squared over 2. From 0 to pi. Then substitute the value for x. You have 1 over pi. Pi squared over 2 minus 0. So you have pi squared divided by 2 pi. So this is pi over 2. You can cancel 1 pi from here. So you have pi over 2. So you are done with A naught. Next, find what is your AN. AN is equal to 1 over L, negative L to L. Fx must be multiplied with cos n pi x divided by L dx. So this is 1 over L. L is equal to pi. Okay. Then we have negative pi to 0. Fx is 0. Cos n pi x over pi, L is pi, dx, plus with, from 0 to pi, we have x cos n pi x over pi, dx. Again, this is equal to 0. And you can cancel this 2 pi. So you have 1 over pi, integration 0 to pi, x cos n x dx. Okay. Now you have to integrate x. X is your u, cos n x is your v. So since it involves multiplication of x and cos n x, you need to use tabular method. Differentiation part, integration part. Polynomial is always on the differentiation part, x. And integration, integrate your cos and x. 1, 0, sin nx divided by n. Then you have negative cos nx divided by n squared. You need to master this tabular method. Okay, so it is equal to 1 over pi. Okay, x sin nx over n plus cos nx over n squared. 0 to pi. Substitution. 1 over pi. Substitute pi. You have pi sin n pi over n plus cos n pi over n square minus 0. X equal to 0. So you have 0. Minus cos 0 over n square. Sin n pi. Remember the helpful identities? Sin n pi is equal to 0. Cos n pi is equal to negative 1 to the power of n. Cos 0 is equal to 1. So you have 1 over pi negative 1 to the power of n over n square minus 1 over n square. Or if you want to simplify this, you can have 1 over n square pi negative 1 n minus 1. So now you have your an. Last but not least, you need to find what is bn. Okay, for bn, I have 1 over L, integration from negative L to L, fx sin n pi x over L dx. So 1 over pi, negative pi to pi, fx is, okay, negative pi to 0, 0 sin n pi x over pi dx plus 0 to pi x sin n pi x over pi dx. Okay, so for this side we have 0. So 1 over pi, 0 to pi sin n x dx. Okay, we are missing the x. Again, tabular method, differentiation part, integration part, x sin n x. Okay, so 1, 0. Sin nx, we have negative cos nx over n. We have negative sin nx over n square. Plus, minus, plus. Okay, 1 over pi, negative x cos nx over n, then plus with sin nx over n square. Substitute the limit of x, 1 over pi, negative pi cos n pi over n plus sin n pi over n square minus 0. Minus plus 0. Minus with sin 0 over n square. Cos n pi is equal to negative 1 to the power of n. Sin n pi equals 0. Sin 0 equal to 0. So 1 over pi, negative 1 to the power of n over n. We can cancel this 2 pi. So the last answer for this is negative 1 over n, negative 1 to the power of n. So now you have your A naught, an, and bn. Okay, substitute into the formula fx. So fx for neither nor. Okay, fx for neither nor, you have a naught divided by 2 plus summation n from 1 to infinity an cos n pi x divided by L plus bn sin n pi x over L. Okay, so substitute a naught. A naught is equal to pi over 2. So pi over 2 divided by 2 is pi over 4. Plus summation n equal to 1 to infinity an. Okay, an is equal to 1 over n square pi. Negative 1 to the power of n minus 1. And then cos n x. because our L is pi. So we can cancel this pi and pi. Plus with your Bn. Okay, Bn is equal to negative 1 over n, negative 1 to the power of n, sine n x. Okay, so the last answer is equal to pi over 4 plus summation n from 1 to infinity, 1 over n square pi, negative 1 to the power of n minus 1, cos n x minus 1 over n, negative 1 to the power of n, sine n x. Okay. Second example, given fx equal to negative x for negative pi to 0, fx equal to x if your x is from 0 to pi, then x equal to fx plus 2 pi equal to fx. Again, our L is equal to pi. This is negative L to L. So again, L is equal to pi. You need to sketch the graph. Of course, A, sketch the graph. B, determine whether the fx is even, odd or neither. And C, find what is fx, Fourier series. So first, sketch the graph. Okay, let's say you have fx here for negative pi to pi, negative pi to 0, it is negative x. So negative x, you know, it is this kind of line. This is your pi. And then for 0 to pi, x, it is a straight line. This line. Okay. So this is your graph. Okay. And again, if I extend this to negative 3 pi to 3 pi. Okay. So this is your period, first period, negative pi to pi. Then you have 2 pi, 3 pi, and negative 2 pi, negative 3 pi. So you just repeat the same line. Okay, so you have this kind of graph. Okay, and B, is it even, odd or neither? No. So if you see this graph, it reflects on y-axis. Okay, so it is obviously an even function. So since it is even function, you can, your Bn is automatically equal to 0. So what you need to do is just to find what is your A naught. Okay, so A naught 2 over L, 0 to L, fx dx. 2 over L, 2 over pi, 0 to pi, fx xx 0 to pi. So this is x from 0 to pi. So your fx is this one. Fx is x. So x dx. So 2 over pi, okay, x square over 2, 0 to pi. So you have 2 over pi, your A naught equal to pi square over 2. You can cancel this. Your A naught is equal to pi. A naught is equal to pi. Then find what is An. An is equal to 2 over L, 0 to L, fx cos n pi x over L dx. So 2 over pi, 0 to pi, fx is x, cos n pi x over L is pi dx. Okay, so 2 over pi, 0 to pi x cos n x dx. Okay, as usual, since you have x and cos n x, do the tabular method, d and I, and then solve for the last answer. So x 1 and 0, cos nx sine nx over n have negative cos nx over n square. Plus minus plus. So 2 over pi x sine nx over n plus cos nx over n square. 0 to pi. So 2 over pi sine n pi over n plus cos n pi over n square minus 0, since x is equal to 0, so you have 0, minus with cos 0 over n square. 2 over pi sine n pi is equal to 0, cos n pi equal to negative 1 to the power of n, cos 0 is equal to 1. So we have negative 1 to the power of n over n square minus cos 0 is equal to 1 over n square. So we have our an equal to 2 over pi n square. Negative 1 to the power of n minus 1. And the last substitution is for fx. Fx equal to a0 over 2 plus summations n from 1 to infinity an cos n pi x over L. Substitute all the values. A0 is pi, so pi over 2 plus summation n equal to 1 to infinity. An is equal to 2 n square pi negative 1 to the power of n minus 1. So this is the last answer for second example. And we have the last example in this video. Example 3. Consider fx equal to negative x. So this is not a piecewise function. You have fx equal to negative x. Negative 1 is negative L. X, 1 is L. Where fx plus t equal to 2. So this is t plus capital T. Period is equal to 2. So L is equal to 2 over 2, means L equal to 1. Sketch the graph of fx first. Okay. Sketch the graph. So this is fx, this is x. Fx is equal to negative x. Negative 1 to 1. So if your x equal to negative 1, so fx becomes 1. Okay. Fx equal to 1. And then x equal to 0, fx 0. X equal to 1, your fx equal to negative 1. So this is negative 1. Okay, this is 1, this is negative 1. So you have this line. And if I extend this to negative 5, x to 5. So you have 2, 3, 4, and 5. X, and then negative 2, negative 3, negative 4, negative 5. So this is the first period. Then just repeat. Okay, just repeat. So you have this 1 and 2. From here, for this you have these 2. Okay. B, determine whether the fx is even, odd, or neither. No. So it is even because you have reflects on y-axis and then reflects on x-axis. So you have odd function. Symmetry on about the origin 0, 0. C, okay, For the Fourier series, A0 and AN is equal to 0. For the odd series. Okay, so we just find Bn. Bn 2 over L 0 to L fx sine n pi x over L dx. So you have 2 over 1 0 to 1 fx. Okay, negative 1 to 1. So the function is the same, negative x. So fx is negative x sine n pi x over L equal to 1 dx. So you have 2, 0 to 1, negative x sine n pi x dx, or negative 2. So again, tabular method involving differentiation, integration, x and sine n pi x. Okay, I move the negative to the 2. Okay, so negative 2. So I have x 1 0 plus minus plus. Integrate sine n pi x become negative cos n pi x divided by n pi. Then negative sine n pi x divided by n pi square. Integration. Okay, so negative 2 negative cos, x negative cos n pi x over n pi plus sine n pi x over n pi square. Limit from 0 to 1. So equal to negative 2, substitute the limit. Negative cos n pi over n pi plus sine n pi over n pi square. Substitute 0, you have plus 0. The sine 0 over n pi square. Okay, cos n pi equal to negative 1 to the power of n. Sine n pi equal to 0. Sine 0, obviously 0. So you have negative 2, negative. So positive. 2, negative 1 to the power of n over n pi. So you can write your fx odd function. So fx is equal to summation n equal to 1 to infinity bn sine n pi x over L. Okay, so summation n from 1 to infinity bn is 2 over n pi negative 1 to the power of n sine n pi x. Since L equal to 1, so we just have sine n pi x. So this is the last answer for the last example. Okay, so we just cover how to find the Fourier series for neither nor function, even function and odd function. In the next video, we will try to solve for the half range Fourier series. Thank you.